Welcome everyone. Today we're going to start our first unit in stoichiometry, and we're going to start with the basics. We're going to learn how to calculate molar mass. This is actually a very simple process. Molar mass is basically obtained using the periodic table. We're going to need a periodic table to get the atomic masses of each of the elements. The units of molar mass is a ratio of grams per mole. It's a derived unit. There's another term called formula mass, and formula mass and molar mass are obtained exactly the same way. The only difference between the two is the units. Molar mass is expressed in grams per mole. Formula mass is expressed in AMU, which is atomic mass units. But essentially, the process of obtaining molar mass or formula mass is basically the same. So what we're going to do is, let's start by finding out how to find the formula mass of carbon tetrachloride. The formula mass will be the mass of the entire compound. So what I'm going to ask you to do now is to be organized until you get to do this quicker. The first thing you want to do is you want to list the elements. Okay, so that'll be the first thing that you do. Each element is a capital letter. So carbon tetrachloride has two elements. It has carbon and chlorine. Then the next thing you want to do is put the number of atoms that you find in the formula. In carbon tetrachloride, there is one carbon and there are 4 chlorines. Once you do that, this is where we need to go to the periodic table. And what we're going to do is we're going to get the atomic masses. Usually, what I ask to do is to go 2 decimals deep, round it to the hundredths place. So when we go to the periodic table, you're going to see that carbon right over here, we're going to use 12.01. And for chlorine, we're going to use 35.45. So let's go back. And let's put the respective atomic masses. So this we said was 12.01. And this one is 35.45. Okay? And once you have this set up, you pretty much have all the work done. So what we do next is once this is set up, we're going to basically multiply these two numbers that you see here. And what's going to happen is when you multiply, you're going to get this last column. So 12.01 times 1 is simply 12.01. And then when you multiply 35.45 times 4, you're going to get 141.8. Now, once you get that last column filled out, you simply add the last column, and you're going to get 153.81. The units are going to be grams per mole. Okay, if it was formula mass, it'd just be AMU, but it would still be 153.8, the same exact answer. Okay, so again, use the periodic table to obtain the atomic masses, round them to 2 decimals deep. All right, so now let's take a look at another example. Let's find the molar mass of dinitrogen monoxide, which is also known as laughing gas. So again, we're going to do this organized. We're going to list the elements first. That'll be our first category here. So we got 2 elements. We got nitrogen and oxygen. And then afterwards, we're going to put the number of atoms from the formula. As you can see, laughing gas has 2 nitrogens, but only 1 oxygen. And then we're going to go and find the atomic mass from the periodic table. And again, we're going to round that to 2 decimals deep. So let's take a look at the periodic table. You could see nitrogen is 14.01. Okay, oxygen rounds to 16 even. So those are going to be our 2 atomic masses. So let's go back and let's put 14.01 here for the nitrogen. And then oxygen is 16. And we're going to multiply over here these 2 numbers to get our final column. So 2 times 14.01 is going to be 28.02. Okay, and then we're going to multiply 16 times 1 is simply 16. And then our last step is add these 2 numbers up that we have here. and you're going to get 44.02. And again, it's going to be grams per mole as your unit, and that is the molar mass of laughing gas. Okay, so again, use the periodic table to obtain the atomic masses. All right, let's try one a little bit more complicated. So let's say I asked you to get the molar mass of calcium acetate. Well, first we got to convert this from a formula, from a name to a formula. So calcium is +2 as a charge. Acetate is a polyatomic that has the following formula. C2H3O2 has a -1 charge. So when we crisscross these to get the formula of the ionic compound, the 1 from the acetate goes to the calcium, and then to show that the acetate gets the 2 from the calcium, you put it inside a parentheses, just like this, and then you put the 2 out here. Okay? So let's use what we've learned, and let's find the molar mass of calcium acetate. So this one has more elements. The first thing you do is list your elements. We have calcium, we got carbon, we got hydrogen, and we got oxygen. Now, let's see how many we have of each. According to the formula, there's only 1 calcium in that formula. So put a 1 there. Now, if you look carefully, remember this 2 gets distributed through multiplication only to what's inside the parentheses. So as far as carbon is concerned, it's 2 times 2. So there are 4 carbons. For hydrogen, it's 2 times 3. So there are 6 hydrogens. And for oxygen, it's 2 times 2. So there are 4 oxygens. Okay? Now, once you put how many atoms you have of each in the formula, we're going to multiply, but we need to obtain first the atomic masses of each of these. So we're going to go to the periodic table. Okay? You'll notice calcium is 40.08. All right, we're going to need that one. We're also going to need carbon, which is 12.01. We're going to need hydrogen, which is 1.01. And then we got oxygen over here at 16. Okay, so those are the molar masses that we're going to need. So calcium is 40.08. And then carbon is 12.01. All of these, again, from the periodic table. Hydrogen is 1.01. And then we got oxygen, which is going to be 16. Okay? Now what we're going to do is we're going to multiply to obtain the final column, which will be the product of these guys. So the first one stays the same, 40.01 times 1. The next one, 12.01 times 4. That's going to be 48.04. And then hydrogen is 6 times 1.01. That's going to give us 6.06. And then we got the oxygen here at 16 times 4 is 64. So we're going to add this up. I'll write the number over here since I have more room. So we're going to go ahead and add 40.08. Let me go ahead and put that in my calculator here. So you got 40.08 plus 48.04 plus 6.06. And then we got the 64. We're going to add all of these numbers up. We're going to end up getting 158.18, and the units are grams per mole. Okay, again, if it was formula mass, it would be the same exact answer. You would obtain it the same way, but instead of the units being grams per mole, you would put AMU. Okay, so that's just a little technicality that in terms of difference between molar mass and formula mass. It's just the unit. So this is how you obtain the molar mass of a compound. Okay?